Okay, so for the second part of the problem, I asked you to do a unit conversion. This is something we have to do a lot in science or also in engineering. So what'll happen is you take all your measurements in the lab, you get the value, and then you have to reference that value to a chart that's found in something like what's called the CRC, which is this $500 book full of tons of values that scientists have collected over the years. And invariably, the values that you have for your measurement don't match the units in the book that you're referencing. So you have to be able to convert from one form of unit to the other. It's just something that we have to deal with a lot. So from the last problem that we did, we saw now you notice I'm making a T-chart right here, but what we ended up with is we had 1 gram per cubic centimeter. Now it said 1 gram per milliliter, but it's important you understand a cubic centimeter and a milliliter is the exact same unit. Okay, so I've got 2 conversions I'm going to have to do. I'm going to have to convert from gram to decigram, and then I'm also going to have to convert from cubic centimeter to cubic meter. So let's take a look at this stuff right here. The first one I'm going to do is, I'm going to go with the easy one, and that's from gram to kilogram. So up here, I put in order the metric prefixes, so we've kind of got a grip on those things. So the first thing we have right here is big capital M, that's for mega, and there's a dotted line, explain that in a second. We go kilo, hecta, deca, no prefix, and then we go deci, centi, milli, and then after the milli, something that looks kind of similar, that's micro, and there's a dotted line there as well. So what does that do? Okay, you've seen the metric prefixes before, you've had these a lot. These go by factors of 10 as we're going across there. Let's see if I can get rid of that. I did, okay. Go by factors of 10. If you're outside the dotted lines, they get 1,000 times bigger or smaller rather than 10 times bigger or smaller. Okay, off to the side, what we kind of want to do is make sure that we have our conversion factors between the units we're talking about. So, let's see if I can do this in a different color. I need a conversion factor between decigrams and grams. What I like to do is pick the bigger unit. So the bigger unit would actually just be the gram than the decigram. So if I've got 1 gram, how many decigrams would be in it? Well, I've got 10 of them. The reason I do it this way is that involves me getting rid of negative exponents, and when you start punching tons of numbers in the calculator, you don't want to say, and you could do this, this would still work, is say 10 to the negative 1 decigrams equals, or how would you do this? Yeah, you could say 1 decigram equals 10 to the negative 1 grams. That works as well, you know, so you could use that, but then you've got negative exponents in there. Now we take this conversion factor and we got to plug it in right here. So what do we want to do? Well, I'm trying to get rid of the gram, so that goes on the opposite side of my little T-chart here. So let's go back. What does that do for us? Okay, so now I've got decigrams per cubic centimeter. What's the next thing I got to do? I got to convert the cubic centimeter into a cubic kilometer. That's going to be kind of a big conversion. So I've got to derive that relationship. This is going to be a bit of a pain in the butt because it's easy to do this part, okay? So I'm going from centimeter to kilometer. So that's the one. What's the bigger unit? Okay, that's a kilometer. So I'm going to say I've got 1. And how many centimeters is going to be in that? Well, I can just start counting over on this. So 10 to the 1, 10 to the 2. Don't forget your no prefix. 10 to the 3, 10 to the 4, 10 to the 5. There are 100,000, or 10 to the 5th, centimeters in 1 kilometer. Now, can I just plug this into the unit conversion factor? Nope, that's going to be a problem. Why? These are actually volume units. It's a derived unit. So I'm going to have to derive the relationship. So it's a centimeter times a centimeter times a centimeter. And the nice thing about algebra is I can do anything I want as long as I do it to both sides of the equation. Well, not anything you want. Can't use absolute value, but most stuff. So you're going to have to cube both sides. So what's 1 kilometer times 1 kilometer times 1 kilometer? It's 1 kilometer cubed. How many cubic centimeters is in a cubic kilometer? Well, I got to take 10 to the 5th times 10 to the 5th times 10 to the 5th. Which is going to give you 10 to the 15th that's centimeters cubed. That's a little off here. Let me see if I can erase that. Starting out. So that's the conversion I'm going to have to go back into and plug into my original problem over here. So we extend out our T-chart. Okay, I'm trying to get rid of the centimeter. The centimeter cube's in the bottom. Now the centimeter cubes will cancel. Okay, now some important things. This stuff in the top of the bottom of what we call a conversion factor have to be equal to each other. There is 10 to the 15th cubic centimeters in 1 kilometer cubed, not the other way around, so you can't mix up the numbers with this. So this and this have to be equal to each other. Same thing would be true over here. If they're not, you've got something screwed up. The other thing is it has infinite sig figs. If I have measurement conversions, like in the metric where I'm just changing prefixes, these numbers right here have no impact on your sig figs. Sig figs are only based on your original measured values. Now, once in a while you can get into something where your conversion factor, you just don't know a lot about the conversion factor, and that could enter into your sig figs. But most of the time, that's not going to happen. In the US, we actually changed, or in the English system, I should say, we've actually changed 1 inch, so it is 100% matches 2.54 centimeters to infinity. Okay, that's the definition right there, so when we convert it's an actual exact conversion, doesn't change your sig figs. So now what I do is I do everything to the top and the bottom here. I've got a 10 times 10 to the 15th. I don't know why I did that. Okay, so our final answer right here is actually 1.0 times 10 to the 6 decigrams per kilometer cubed. So that's about as tough a unit conversion problem as we would see in any of the chemistry stuff we're doing. But you're going to have to do some of these things, especially if you go far enough in science. If you got questions, be prepared to ask me some of those, not on Thursday, but a week from today, which would be Monday. All right, so if you got the right answer perfectly on this for the right reasons, awesome. You really understand all this stuff. If you made a mistake in there, don't worry about it unless you don't understand the mistake you made. All right, talk to you soon.